All right, so here is the second part. Kind of open that up a little. Okay, so where I left off last time was that time equals v naught sine theta over g. If you don't understand this, go back, or you're not sure what you can actually measure, you need to go back and check out the other video. So this is all well and good, but if you look up here, you know your g, you know your acceleration due to gravity. This was for time, and this is time 1, the time it takes to reach its highest point. We're breaking it up, but when it reaches its maximum height. Okay, and then your final velocity there, because it's at its maximum height, we stop looking at it right here for this part, is 0. The height is just going to be the height it goes up above where it was launched. We don't know that, and we don't know delta x1. So anyway, you're going to, this looks good, because you have the g, you have the theta. The only problem is you don't have this v naught. The video I'm going to show you right now is how to find v naught. So the main thing to remember is you only have one acceleration, and that's in the y direction. It's acceleration due to gravity. So that means that, actually let me do this in a different color. That means that your v naught cosine theta is the same every place on here. So it's the same, I'm going to highlight this, it's the same v naught cosine theta here is the same as v naught cosine theta here. And it's going to be the same thing at the end of this as well. Okay, so black pen. All right, so, well, it's not letting me pick that. Okay, so basically, if you look at this at the very end, I'm going to draw it. You can draw it up here. I'm just going to draw it down here. It really doesn't matter. This is going to be your final velocity, like what your velocity is at this particular, right before it hits the ground, like just a split second. Okay, so I'm going to draw that this way. You see that's a negative overall. And since I called the other one v naught, like your initial velocity, I think I'm just going to call this one v. All right, and you know that some of that is going to be your final velocity in the downward direction. And I had shown some of y'all how that's like v sine theta, and this is your angle right here, and that's theta, I guess theta 2 for this, but you're really not going to need to deal with this. Let's just call this v y, or v final 2. I guess, or whatever you want to call it. That's just like your downward. And since we're going to use unit vector notation and not have to find the angle, that's fine. But this, your horizontal component of this, is still v naught cosine theta. It does not change. Anywhere on here, it's moving over the same way because there's nothing to stop it. There's nothing to slow it down or speed it up. It's just going to keep doing what it does. So that makes things pretty easy when we look at this. You've got your change in position overall, right? You've got your total time. Those are the easy things to measure, like where your projectile hits and the time it takes. So if you look at this, you've got your delta x over your time. And that gives you average, it's an average velocity in the x direction. Well, the great thing about that is since that velocity does not change because there is no acceleration, that we don't care about the average. This is what it is. It's your velocity in your x direction. So if you look at this, your v naught cosine theta, all right, v naught cosine theta, okay, that equals the same thing, v sub x, all right? So if you look at these two things together, you have delta x over time, and that's equal to v naught cosine theta. And I'm going to kind of put this in parentheses because guess what? This you can find. Cosine is just like something you plug into a spreadsheet or a calculator or something, and theta you've already measured. So let's just solve this for v naught. I'm going to put this over cosine theta. And those cancel out. And then this, I'll just let me extend this, and I'll put time cosine theta. Squeeze that in there. And that totally works. You've got what your v naught is now. So you're good on that. So you could actually find this, multiply this times sine theta to get this. Or if you put it in a spreadsheet, you could have a column for that. Anyway, so yeah, that's how you would find your V naught. That would make things a whole lot easier. And see your V naught cosine theta right here? You can just plug in, oops, you can just plug this in, oops, up here, instead of the V naught cosine theta if you like. And that should make things a little bit easier. And then you can solve for your h, you can solve for x1. The other part of that is, once you have all of this information, like let's say once you get x1 and you know that you have x total, all right, guess what else you can find? Delta x2, because the x, oh that's supposed to be a delta, sorry, delta x total equals delta x1 plus delta x2. And if you already have this, because you can solve for it here, and you already have this, you're good. So that works, okay? And your time, same thing. If you know your total time, okay, that's just time 1 plus time 2. Okay, and same thing. Here, you're going to start this off. This is going to be your maximum height for your second half of this problem, which I'm not going to set up. You should be able to do that. All right, you're going to set that up like that. And you would add this height 2, which is this portion, to your launch height, which is this part. See right over here? So if you look at, I'm going to call that H max. This, all of this, the highest point it goes, call that H max. Okay, so your H max equals height 1 plus height 2. So yeah, if you've already measured height 1, if you're able to solve for height 2, which you should be able to, that should be pretty easy. And this will be things that you can put numbers in. And I'll probably, here in just a second, show you how to set up a spreadsheet from this. But keep this in mind. So yeah, and your last one, you don't need to solve for x in the second half of this. You can just solve for your final velocity. But anyway, that should do it for this one.